Oh, hi, friend. Sorry, I didn't see you there. Don't mind me. I was just looking at this giant book. I suppose you are here about populations. Yeah. So, populations are a level of study of ecology, and a population encompasses a group of a single species living within the same niche. And so typically we just define the population by being in the same area. And so I could have the populations of humans in Lynn. That's a possible population. I have the population of bacteria in my mouth, right? Specific species of bacteria, E. coli. Okay, I have a population of E. coli in my mouth. If you think back to how our speciation occurs, however, sympatric speciation, right, involves two different populations of the same species in the same area. And sometimes they don't mate because they live in different niches. Right? So if we want to get really specific about it, we do have to get down to that niche level. Right? But typically we can think of it as being in the same area. And that area can be whatever you want to define it as. And so when we are studying populations, one of the major things that we look at is population size, and more specifically, changes in population size. Those changes can be indicative of the health of an ecosystem, the availability of resources of an ecosystem, and the overall goodness of an ecosystem. Okay? Or badness if this population is, invasive species or something negative like that. So when we're assessing population size, we have a very simple formula, a very logical formula. We have the births plus immigrations, two things that make our population go up, minus our death and emigration, two things that make our populations go down. Okay? So you take the two numbers, you find the difference, and that's your population change. Okay? If this side is higher than this side, my population is increasing. If this side is higher than this side, my population is decreasing. Now, left without restrictions, populations will grow exponentially because reproduction is an exponential process. Okay? And so the more organisms that I get, the more they can reproduce. So I have this very quick exponential growth curve if there's no limiting factors holding back this population. At some point in time, the population is going to hit a wall where there's not enough resources for it to continue its growth. Okay? And so it'll go up a little bit over that wall and things will start to die. It'll dip below that wall and then it can go back up and go back down and go back up, and go back down, back up. So we call this little level where it kind of steadies off the carrying capacity. It's where the population size is comfortable within this particular ecosystem with the available resources. Okay? So that's what we're looking at for populations. Cool? Bye.